Good day to all of us. I am French Derivation, and I am a student at Agusan del Sur State College of Agriculture and Technology, Bachelor of Secondary Education, major in Mathematics. So, my title of my topic is
Derivation of Trigonometric.
I'm going to discussing the fundamental trigonometric identities and circular function identities. So, from our unit circle, our radius is 1. From the point of origin to the right, that is equal to 1. Our horizontal or the x-axis and the vertical is y-axis. We know that in our unit circle, x is for our cosine and y for our sine. That's why in our fundamental trigonometric identities, we have the reciprocal identities. In our reciprocal identities, if we have cosine theta, the reciprocal of cosine is secant. So we have 1 over secant theta. Then sine theta is equals to 1 over cosecant theta. Tangent theta is equals to 1 over cotangent theta. So from our letter A identities, we can derive another identity. So let's say we have cosine theta is equals to 1 over secant theta. So to derive, secant theta is equals to 1 over cosine theta. Sine theta is equals to 1 over cosecant theta. To derive, cosecant theta is equals to 1 over sine theta. Tangent theta equals 1 over cotangent theta. So to derive, cotangent theta is equals to 1 over tangent theta. So another is ratio identity. So we have tangent theta is equals to sine theta all over cosine theta. We also have cotangent theta is equals to cosine theta all over sine theta. So going back to our range identities, from this case, or we can derive another identity. So cos multiply. So we have tangent theta, cosine theta is equals to sine theta. Same case, cross multiply. Cosine theta is equals to sine theta, cotangent theta. So, since we are dealing with the unit circle, we have the Pythagorean identities. From the Pythagorean identities, let's say our unit circle, we're going to create a right triangle. Then I will transfer here the right triangle. Then unit circle, our radius is equal to 1. Our vertical line is y, and horizontal line is x. So now, recalling our Pythagorean theorem, if we have a squared plus b squared is equals to c squared. So in this case, our a is x. So we have x squared plus b is our y, that is y squared is equal to c squared, that is our radius. So 1 squared. 1 squared is equals to 1. So from here, we can derive our identities. We have x is for our cosine. So we have cosine squared theta plus y is our sine. So plus sine squared theta is equals to 1. Again, from here, we can derive another formulas. We have sine squared theta is equals to move to right. It should be 1 minus cosine squared theta. So next, so if we want to get the value of cosine squared theta, move sine squared theta to the right. So cosine squared theta is equals to 1 minus sine squared theta. So from our first identity, if we're going to divide the cosine squared theta plus sine squared theta is equals to 1, if we are going to divide by cosine squared theta, that will give us cosine squared theta divided by cosine squared theta is equals to 1 plus sine squared theta sine squared theta over cosine squared theta, that is equal to tangent. So we have tangent squared theta equals to 1 over cosine theta this is from our reciprocal, 1 over cosine is equals to secant squared theta. So, we can get our three identity. This case, we're going to divide sine, this sine squared theta. So, cosine squared theta plus sine squared theta is equals to 1. Divide by from sine squared theta, both side rather. So, cosine squared theta all over sine squared theta is equals to cotangent squared theta plus plus sine squared theta all over sine squared theta is equals to 1. So the 1 over sine squared theta from the reciprocal is cosecant squared theta.